The moon, our constant companion in the night sky, always watching over us. It's a natural wonder that has captivated humanity for centuries, inspiring countless myths, legends, and scientific inquiries. But just how long does it take to travel to this celestial neighbor? The journey to the moon is a remarkable feat of human ingenuity and perseverance. The answer isn't as simple as you might think. It involves a complex interplay of technology, physics, and mission planning. The moon orbits Earth at an average distance of 238,855 miles. That's a long way. To put it in perspective, that's about 10 times the circumference of the Earth. The time it takes to travel to the moon depends on several factors, including the mission's goals, the type of spacecraft, and the chosen path. Some missions prioritize speed, aiming to reach the moon as quickly as possible. For instance, the Apollo missions took about 3 days to travel from Earth to the moon. Others prioritize a safe landing, taking a more cautious approach to ensure the safety of the crew and equipment. This variety in mission goals leads to a wide range of travel times, from a few days to even longer durations for more complex missions. It's a fascinating puzzle of physics and engineering, showcasing the incredible capabilities of human innovation and determination. Imagine you're driving a car. The faster you want to go, the more gas you'll use. Spacecraft work similarly. More fuel means a faster trip to the moon. However, more fuel also means more weight. Launching a heavy spacecraft is expensive. Engineers are always looking for ways to conserve fuel. One method is called gravity assist. Gravity assist uses the pull of planets to slingshot a spacecraft towards its destination. This method saves fuel, but it takes longer. It's a trade-off between speed and efficiency. Over the years, we've sent numerous missions to the moon, each contributing to our understanding of space travel and lunar exploration. Each mission has had a unique travel time, influenced by the technology and objectives of the time. The Soviet Union's Luna 1, launched in 1959, reached the moon in about 34 hours, marking a significant milestone in space exploration. It was the first human-made object to do so, paving the way for future missions and demonstrating the potential of space travel. The famous Apollo 11 mission, which landed humans on the moon in 1969, took longer, reflecting the complexity and ambition of the mission. It took about 109 hours to complete its journey. Why the difference in travel times between these missions? Apollo 11 aimed for a safe lunar landing, which required meticulous planning and execution. This required a more precise trajectory and numerous course corrections to ensure the safety of the astronauts and the success of the mission. These historical missions show the range of travel times and the evolution of space travel technology. They also highlight the careful planning required for space travel. Every minute detail matters, from the launch to the landing, ensuring the mission's success and the safety of the crew. As we look to the future, each new mission builds on the lessons learned from these pioneering journeys, pushing the boundaries of what is possible in space exploration. Section 4. Journey to the Moon, a step-by-step guide. Every lunar mission, regardless of its duration, follows similar steps. First, the spacecraft must escape Earth's gravity. This requires an immense amount of fuel. Once in space, the spacecraft adjusts its course toward the moon. Next, the spacecraft performs a trans-lunar injection burn. This maneuver propels it out of Earth's orbit and towards the moon. As the spacecraft nears the moon, it must slow down. Finally, the spacecraft either lands on the lunar surface or enters lunar orbit. Each step is crucial and requires precise timing and calculations. Section 5. The future of lunar exploration. The journey to the moon is a complex endeavor requiring meticulous planning and cutting-edge technology. Travel time is just one piece of the puzzle. The logistics of sending humans and equipment safely to the lunar surface are immense. As technology advances, we can expect to see even faster and more efficient lunar missions. Innovations in propulsion systems and spacecraft design are paving the way for a new era of space travel. Imagine a future where traveling to the moon is commonplace. Regular lunar missions could become a reality, opening up new opportunities for exploration and discovery. New technologies might allow us to build lunar bases, providing a permanent human presence on the moon. These bases could serve as hubs for scientific research and exploration, or even mine resources on the moon. The possibilities are endless. Lunar mining could provide valuable materials for use on Earth and in space. The moon has always held a special place in our imaginations. Its mysteries have inspired generations of scientists, explorers, and dreamers. As we continue to explore our celestial neighbor, we'll undoubtedly unlock even more secrets of the universe. Each mission brings us closer to understanding the moon's history and its potential for future exploration.